Yo, what up, gang? How's it going? All right. All right. Yo, hello, everybody. Welcome in. Hope you're doing okay today. Let's go ahead and get started. Um, I haven't streamed in a couple days. Just been kind of chilling, honestly. Um, with the job market just keep getting worse and worse. Um, I've really just kind of taken the pressure off of applying to places, dev wise, and just kind of being like, yo, I got a job in biotech, so got to be grateful for what we have in these dire times. So I'm kind of just taking a step back um, and started playing more guitar, started, doing some other stuff. Um, I'm moving into a new place here in less than a month, so I got a lot of those things kind of going on as well. Let me go ahead and throw some socks on real quick. I don't really like not having socks on. Um, and then we'll go ahead and get started. All right. Let's go ahead and get started today, you guys. Um, a CD into. I made this new repo, Stonks. Conde. Okay. Cool. Let's go ahead and get started today. So today should be a fun one. I'm gonna try to code quickly here, but also efficiently in this session. I haven't programmed in a few days actually. I've been kind of just taking a chill. So it might take me a second to kind of get back into the flow. So don't laugh at me here. But we're going to get started. And yeah. Hey, what's going on, Matt Have? Welcome in. Thanks so much for joining me. All right, you guys. Um, so the goal for today is I would like to build a backdating calculator. Um, I would like to given I saw this guy post on Reddit this chart of the T triple Q, and it was pretty cool because it showed like, okay, if you invested X amount of money at the given, year or whatever, um if you invested X amount of money at some given year, what would be the return from then on forth in a 2D in a two-dimensional matrix. And I thought that was a pretty cool visual representation, and I kind of wanted to recreate that here. Um, but kind of make it so that I can plug in any value, initial X starting investment, and then um, any ticker symbol that I would like via from Yahoo Finance. So let's go ahead and pull up our Y Finance docs here. I haven't used it in a while. So I'm gonna have to remember here how to use it. It's been a while since we wrote some Y Finance stuff. Um, so just ticker, and then you can get some basic data from some method polls, and you can have tickers via a list or a tuple in this object via tickers. Okay. Um, History is probably what we're looking for. Okay, it shouldn't be that difficult then. Pip install Y Finance. Okay, so let's go ahead and python -m venv dot venv. So that'll make a virtual environment. Maybe we did it wrong, but we have the virtual environment now. I think we have to do .venv slash bin slash activate if it didn't do it automatically. Let's go like this. Usually what happens if I open up a new command terminal and it'll automatically hmm. I always forget. Ah, that's what I did. Maybe I wasn't in the right Python. Okay. Now did that give me a bin activate? Yeah, it did. Okay, so I think something just was up the first time. And then if we do .venv slash bin slash activate permission denied. Oh gosh. We have to run it. I forgot. I always forget this part, but whatever. Usually it'll load up an automatic. Oh, I'm not signed in. Something's going on here. Why is my VS Code all being strange here? No, I don't want to start using AI features. Just let me. Oh, that's a different sign in thing. Oh, never mind. Okay. Sorry, guys. It's been a couple days. We're out of the flow here. Okay, we're back. We're good. Okay. Hey, how's it going? Hey, Arian. Hey, Vlad. Hey, Michelle. Hey, Cody. Hey, Matt Have. Welcome back in, dude. Why not C? Just shaking it up. I like writing in both. Python's good for like stocks and data science, quick API pulls, and backend stuff. So um, it's just different stuff for different stuff. um, um, I don't stream on Twitch. Well, I used to, but I don't have good enough Wi-Fi right now. I will when I move into my new place to do the multi-stream. We didn't finish the shell yet, no. It's a pretty long course. There's like 75 steps. I think we're on like step 20 or something. Hey, Justin, welcome back, dude. Let me know what you guys are working on. All right, let's get started here. Okay, so let's install Y Finance and let's set this up accordingly. So this gives you back a data object, and so we'll see what this oop, no, phew, pulled that away just in time. That could have been bad. Okay, so we do here. I showed you guys my spam emails. Oh no. Okay, I'm working on making a game in C++, which I've been streaming at. Also just got junior full stack engineer. Oh, dude, nice, Justin. How's that been going? You got to share some words of wisdom with every people here. People in the Discord been talking about how they've been struggling with job apps. Feel bad, man. It's tough. It sucks. Okay, so let's go get into this. So I'm going to make their main or no, what else? Code main. Oh shoot. Oh, okay. So let's just quickly. We'll probably set up a little bit more structure here, but just some rough. We'll just follow the suggested here, and then as YF, and then we have data is equal to, or we'll just say stock is equal to YF dot ticker, right? So you have this ticker object which takes in some sort of stock here. So then we'll say we'll take a ticker symbol variable, and we'll set that equal to just right off the start here, Microsoft, and then we'll do upper just to keep it safe, and we'll also strip. Okay, so we have the stock, and then we can get basic info, calendar, analyst price targets, quarterly income statements, and history. So I'm more relevant and interested in the history for this one. So stock dot, we're gonna print, let's print the type of stock. Let's print let's print the let's print the stock itself. Then let's print stock dot history here and see what we get. Okay, so we get the stock is a ticker object. If you print stock, it gives you just an object of Microsoft. Okay, and then bound method ticker history wine and finance Microsoft. Okay, cool. Um, so I guess you have to provide it a period in history equal to, we'll say 10. What kind of periods can you give? Where is like more information? Advanced. Here we go. Stock history. Gives you back a data frame. Okay, but it doesn't give you any periods to Repair default values depends on whether, of course, the repair price with history. I want this history object. I guess let's just copy the original setup here just to see if we can get it working for now. Which is 1 month. And then we will run okay. So now we get the data frame itself. We have to provide the period. Okay, good. So we can get 1 month back. This gives you an open. Let's just print dot head. And then let's just say 5. So that'll print the first 5 columns or 5 rows of this, okay. And then this gives us open, but how do we print all the columns? I forgot. I'm gonna need to go to Panda, shoot. From record, from dict, read CSV to CSV. Okay, so let's actually just do this. Let's go with open. We'll open a file called like just history, or say history.csv, and then we're gonna write this in write mode. As file. Let's go ahead and do this. We'll go ahead and we will get history, all of it from 1 month, and then we will say this is df is equal to this. We'll go df dot to CSV, and we'll write it onto file, and then that'll be fine. And so then if we run this, we should be able to get this into a CSV, hopefully. There we go. Okay, so now we can see high, low, close, volume, dividends, and stock splits. Nice. Cool. So now we have that data frame that we can easily see and parse through with pandas. Really nice. Now our goal here is, given a history, we want to see how much history we can find, and then we want to simulate, we want to clean it up for, okay, so we would need like a year. Okay, let's get started in chats. It's been hard. Good man, definitely hard not coming from web dev background, but definitely blessing. Been mainly doing front end React. Oh, cool, dude. How's it? You're gonna have to teach us more React tricks when we get there, Justin. Or we'll have to ask you to help us. Maybe you help you write our components. What's up, dude? What's going on? I definitely want to start learning more outside of work. Imposter syndrome is so bad. Just came back to streaming on my channel after 3 weeks or so. Oh, nice. Dude, no, I don't really have any tips for. I'm not that good at React. I just know the very bare bones of getting by with front end stuff, how to build components, how to route components together, some basic JavaScript ternary statements to make just components show or not depending on various things. Use state, use effect, use nav, and that's about it, dude. It doesn't really take too much to get like a basic site up with React, but there's definitely a big rabbit hole there's further to go down. But I feel like imposter syndrome with that one too bad. Any advice on note taking in programming? Um, Yeah. So if you guys are familiar, we do a lot of live learning here. That's primarily the content on the channel. Is I found that a lot of people don't really post themselves like in a total honest brutality learning through the struggle, through everything with no edits and nothing. So I do that by watching various college lectures, you know undergrad, master level lectures, going over stuff, learning things, implementing our own projects based off of what we learn, all that kind of stuff. But I do take notes while I stream for my GitHub repos for you guys to reference. And I'll be honest, I don't really go back and reference them too much, um, because it's a lot of information. I mainly do the notes for just the solidification in the moment, right? It does help to solidify in memory, duplicating the information in your own words, but also providing them to you guys. But I am pretty bad and guilty myself of not really going back through, which is something I really need to get better at. And reading them. It would be really easy to just do like a quick pass, right, man? So I need to get better at that. But I I sorry, I lost my train of thought here. Um, uh, for note taking though in general, um, it's really kind of difficult though with programming because there's so many like niche little things, and it's honestly like taking notes when you're in math class. Like it's pretty hard to like take notes without just like copying down like examples or like definitions. Like that's kind of like the core bits of notes is like defining key terms and showing examples with screenshots. It seems kind of like funny, right? You're like, well, that how's that teaching you anything? Well, you have to think that like, well, a lot of programming is just bits, right? It just comes down to bits, and then how those bits are interpreted and abstracted in different ways, level by level by level, and created wrapped around into data classes and data structures and algorithms, and so it's all of these human-made concepts apply. Math that are, you use math, right? But they're like human applied concepts into programming. So you kind of just have to learn the definition and how they're implemented, and maybe through an example because it's pretty visual, through the typing aspect of it. English or whatever language it is, um, programming language, and so that's kind of how I go about the notes really, and I don't really try too hard to be too detailed because you can always honestly go back to the video and watch. It's not like that. That's the blessing I guess I have with this format is I can always go back to those YouTube videos and watch them again. It's always difficult when your Canvas closes at your private institution that you're going to because you can't go back and watch those lectures again. So it's honestly kind of crazy actually that I think about it that you pay for those courses and then you lose access to the courses later on. It's kind of like I wonder if that's like maybe now that I think about it, like a potential legal issue, or maybe when you sign up and like you become a student, you like it's in the fine print if you um like technically like I can't get into like those old Canvas lectures and look at the work that I paid for, right? Or the lectures that I paid for at Utah State, right? Because it's not a private, but you have to pay. It's not they don't post their lectures publicly like Stanford or Harvard or whatever. So it's kind of like that idea with video games. Like, dude, they shut off the servers and you can't get access anymore or whatever to the game. So it's kind of interesting, actually. Like, I paid for this education that if I want to go back and remember more, like, it's solely on my own note taking. So I wonder, like, maybe it's against copyright to even like rip the videos, but you paid for the videos if they uploaded them to your Canvas and you rip them while you're in the moment. But I don't know. Is it like an ethical dilemma? What do you guys think? Hey, Daryl. Welcome. You guys could leave a like. Appreciate you joining me here. We're almost to 9,000. We're halfway to 9,000. That's kind of crazy almost. What's going on, you guys? Okay, let's keep pushing here. And you get good at hooks. Oh, you're a dad now. Nice, dude. Congrats, man. That's so awesome. Justin, you should do a TypeScript tutorial video and I'll watch it. I need to learn that. I downloaded it for one day and then went back to JavaScript because I was like, I'm not doing this. I gotta move faster. Okay. Okay, so we're back. We got our data frame. It's pretty easy with, a couple lines of code. We were able to get the history. So let's see if we can go back 10 years. Oh, it's one. Okay. Oh, let's see. Can you go back max? Oh, okay, so we'll give a period, I guess, and you can have it be. Actually, we'll say periods, and we'll do a tuple here, and we'll copy these periods. I'll have to wrap them in parentheses though, which is kind of troll, but whatever. Hold, be quick. And then what we'll do is we'll use period, periods, key index of, oh shoot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Index of 10. Okay. So it should be fine. Okay. Boom. Okay, now we have max history of Microsoft here. Holy crap. Over 10,000 rows of data. Dating back all the way to 1986. Wow. It's kind of crazy that 10,000 rows doesn't seem like that much data, but that's the entire stock daily high low whatever basic data history of Microsoft. Like from inception, you're like, wow, that's actually a lot of data. But 10,000, it just goes to show you how like numb we are to bigger numbers, and but it's not that big of a number. I don't know. If you still have your school email, you can use the Canvas API to access it. Oh, dude, that's pretty cool, Justin. You should make that on GitHub. You should post that. And actually, I think that would be a pretty cool project if you've already made it. And Canvas still gives you access if you have the school like your email. But do you have to have your school password? I'm not sure if like I remember I got like I got an email from my my college like a couple years after I graduated saying like my student email would be deactivated or whatever, and I think that's what was used through the Canvas. I'm not sure. um I won't lie. Hey Cody, how's it going? I won't lie, man. I was watching vids, doing boot camps, doing courses. Once I bought Python crash courses, so simple to go back if I need, and so in depth. Yeah, dude, it's honestly that I think like having it's kind of like tailored like to kids in a way. Like it uses very like um, elementary examples: dog, cat, car, pizza, and kind of uses very like childish language. But I mean, think about how fast kids learn and how quick they're able to pick up these things. Like some of those like if those parents that make their kids learn programming and give them those types of resources. I mean, why not like try to go back and learn like a kid? Make it easy on yourself. Like make the language simple. Yeah, I have a job. I'm a biochemist. My job is more like equipment admin and maintenance right now for like some genetics machines and things like that, and dealing with service engineers and service contracts and more along the like a lot more admin stuff. I was in manufacturing for 4 years in chemical manufacturing and controls, building and doing. I wrote some code and stuff in that job too, which was pretty cool. I like pitched. I learned how to write code and then told my managers and my manager's manager that I can write code and I can do some cool stuff with what we have, and I implemented some cool scripts and software that we have that they're still using, which is pretty cool. And so, but I moved to a smaller market so I could, you know, um, eventually get a home and start a family one day, maybe. Who knows? But I'm still near the area of the Bay Area. I think if you can still log into Canvas API, you may still be able to access the Canvas course content. Might have to see if your university would give you access. Have you seen the Jordan Has No Life videos for system design? Would love if you watch and learn along with you. Okay, Tree Frog, link those in the Discord so we don't lose them, and let me so I can reference them back. And yeah, we'll take a peek at them. System design seems something I want to definitely take a peek at more. Okay, sorry, we're getting distracted here. So we have all of Microsoft's history. Let's go ahead and so what I want to do is I want to simulate uh, if you were to buy, like, right, given a um, we'll say investment, right? Let's say even an investment of 10,000, an integer of size 10,000, so $10,000 into Microsoft, right? So what we're gonna do is go through this history data frame, and we're gonna create a new data frame of equal size, right? We're gonna create a data frame of equal size, and what we're gonna do is simulate if you bought $10,000 in Microsoft at each year, what would be the return? What would be the return at each year? So how I'm thinking about this is we'll have a graph, which will be, like, which will be rows and columns or whatever. But you don't kind of have to worry about that right now. And so on the x-axis will be percent return, right? Maybe we could make it different. We could have different options like percent return, right? Instead of percent return as well, we can make it as a flag in a parameter of the function, and then just have some conditional logic to change the math, right? So we could have it be for percent return, or we could have it be for um, just total return rather, right? Or actually, it would be like total, not total. I guess the easiest thing to do for right now, and then we can worry about adding different elements later. Let's just keep it simple. Is just um, what's it called? I forgot the word. It's right there in the Robinhood, though. I know exactly where it is. Yeah, the market value, right? So we'll have the market value be on the x-axis here for each column, right? Column is market value, and then um, I guess these are going to be like years, right? Okay, and so in each cell, so you initially have like 10,000 in each cell, right? Because you initially invest 10,000. And then in the next year, you'd have like 11,000 if they went up, or 12,000 in the next, or let's say it went down and then you had like 9,000, right? Blah, 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 blah. So and then what we can do is we can use JavaScript and write it to a front end. Just send the 2D matrix to the front end and have them do some color grading over it to give it some visual, and I think we'll be good there. Um, Gojo, I didn't code the past like 2 days. I was feeling guilty, man. Thanks for making me feel better though. Oh, you went to BYUI, Justin. That's cool. That's pretty near to where there was quite a few people that would come from that school down, and I went to Utah State. Um, I had a kind of like some alumni scholarship, so it's just I kind of wanted to get out of state. I started at community college back in Portland, where grew up. I'm from Oregon. Okay, so let's go ahead and get started here. So what I'm gonna do is I want to create a data frame. I guess we have data is equal to a list, right? We have data, and then we're gonna have um, so this is the history is a row, right? This gives us all the data for the past, whatever. So we really only care about if you invested $10,000 since inception in 1986, right? If you invested $10,000 since inception in 1986, you'd only really care about the yearly return. Right? So we want to look for the same thing. We'll just cast the first four to an integer, increase it, and look for where we match that value, and that's how we find the next year, I think, pretty easily. A year from the start of the first date. Okay. Or we could just say screw it and go by every January if you invest at the start of the year rather than at inception. What do you guys think? Should we do it at inception of the IPO, or should we do it by um, just every calendar year in January? Either way, it wouldn't be too hard to clean, but I think the cleanest way to do it would be by calendar year. So I think that's what I might go with. But Inception could be interesting as well because IPO is pretty interesting. But um, okay, so we'll do it by calendar year. So we have data here, and we're gonna create. Um, well, what we need to do. Oh, this is kind of actually more hard than I thought. I got to think this through. Is we need to create a 2D matrix, a pandas data frame that is not the same size because we want to go by years. So we want to find out how many years this has been alive, right? And then that is how many rows that this is going to be, right? Also by how many columns, because you would do every year if you invested by how many years it would have been. Let me think here. If you invested in 1980 at the start in the first row, if you invested at the 1980 in the start in the first row, or whatever, 1981, 82, 83, 84, when it comes consecutively. Okay, so it would just Okay, let's just be simple and let's do it for one row, I guess. And then we can do it for all the rows from then on forth. But then we can optimize from there, I think. So if we look back at our data, we have 1986 is our first day. We would go through and identify the first day of the year after where the years change. Okay, so we'd have like current year, keep a track of that. Um, hmm. Still thinking this through, you guys. Kind of doing it here live, how I want to do it. So this is the data. Okay, so we can just go. If we loop through each row in the data frame, we can pull out its date and identify if the month, okay, changes. Okay, that's the first date. Okay. Let's just do it every year since IPO. Right, so IPO starting date is this. So we say let's say that IPO year is equal to um, data frame um, I think this is how we would do it, right? Oh, how would we do it? We do dot I locate axes that we're looking to locate on. On the 0 axis, we're going to look up. We're going to get the date value, right? So if we print the IPO year, it takes 1 to 2 because number 3 we're given. What? The IPO I locate is incredible. I sports interest rates and 16 only. Oh, okay. Okay, that's just locating. Sorry. What? No way. The correct syntax uses square bracket indexing. This retrieves the value at row index 0 column labeled data if used int. You intend to select by integer position. Like this. Okay. So it's with brackets. I always forget with pandas after a while. What? Key error date. Key error date. Okay, let's try iLoc index 0. Maybe it's lowercase, but it's uppered in the... That's what we're getting. No. Bro, I don't do like one C stream. I do one Python stream again, and people think I quit doing C. It even has parse date constants. Locate date. PD.timestamp. So you do data frame date to look at all the date columns and locate. Ah, okay. This is where the AI is useful for getting better answers. Let's see this. For pandas, data frame square brackets are used on parentheses. This gets in the value row 0, column data of data frame is a default integer. I got a key error here. Okay, so let's print. Let's print data frame dot columns dot to list, like that. Open. Ah. Really? Oh. It's not including the 0 column. It's the index. Okay. That's why I forgot that it's the index. It's not the actual. Gotcha. So IPO date is equal to the data frame dot index and key of 0. Okay. Then we print IPO date. We have this. There it is. Okay, cool. So then what we can do is we have I think what we can do is we have date. This is a import date time as, or we'll say from date time and time zone. So we have, we'll call date time on our, it's going to be, this is going to be the time zone. From, I think it's timestamp, the IPO date. We'll print the date property of timestamp. From timestamp object cannot be interpreted as an integer. Maybe it's from ISO format. From argument must be stir. Okay, so if it already is a timestamp then, I guess. So let's just do IPO date and see what happens. Bound method. So we print .date. What if we play it as a function? Okay, now we get the date. So what if we print year? No callable object year. And if we maybe we just have to cut the first four. Okay, as a property. Okay, cool. So actually we don't need to convert it to a data frame at all. A date time already is built into Finance, it looks like. So what we can do now, so our goal here is we're going to go through and identify the percent return So we can write this algorithm pretty slow, right? It'll be O of n square if we do it where we go row by row and then go column by column. But what if we instead do a row Okay. So if we do, because we could get the next go year by year, right? So you you're on the current year, you fill it in, then you move on to the next year, right? So what we're gonna do is I guess what we can do is we can identify how many runs we're gonna do or how many like loops by taking the IPO date year difference between current year and then. So if we do um, our epochs is equal to integer IPO date dot year, and what we're going to do is take less this from I guess we'll go import datetime, right? So we'll do datetime dot today dot year. I think we can take this. So if we take datetime today dot year minus the IPO year, that'll give you how many epochs we're going to loop, right? So that's how many years we're going to calculate. And so what we're going to do is we're going to have results is equal to, we have data already down here. Right, so results is equal to this. Let's see if this works. Perfect. So it's been 40 years that they've been IPO'd. Perfect. This is their 40th year. Congrats, Microsoft. You're getting absolutely destroyed in your 40th year since IPO. Okay. Now what we're going to do is we're going to loop over the epochs, right? This is going to be how many rows in our results we're going to calculate. And for each row, okay, let's think. For every year in epoch, right? Now this isn't going to give us every year. I guess what we're going to need to do is, this is 0. I guess I will do in the range of epochs, right? That'll give us 0 through, so 40 epochs giving us 0 as year. And then what we'll do is we'll have years be a list, right? That's going to be int x, or sorry, x for x in range IPO date dot year. I guess what we'll do is I guess we'll just save IPO year as a variable, right? So we don't have to keep calling this property over and over again. And then we'll cast it once, right? And then we'll just use the IPO year here. And then what we'll do is current year. Right? And then we'll take current year here. Okay, so now we have this. So current year is, now we have those variables extracted out. So we have range of IPO year. And what we're going to do, actually, sorry, it's going to be start, it's going to be IPO year. Stop is going to be current year plus 1 to include the current year, right? And then that'll be years. And then I guess we don't even need epochs then, because we're just looping over every year. So actually, if I print years here, there we go. There's all of our years. Oh, I'm so freaking good. Okay, cool. Now we don't need that, so we can just loop over our years. So for year in years, right? Because I was going to make a list of years and then use our epochs to index into the list of years, but we don't need that. We can already just loop over the list of years. So for years, right? The thing is we are not looping over years. Is we're trying to we need to loop over the pandas data frame. So, and then go year by year from there, right? So, so we loop over the pandas data frame. We would say We loop over the pandas data frame, which has every date, high, low, close, right? Well, we're going to compute only years from IPO if you were to invest. Okay. Should have planned this out more. What we want to do is we really want to oh, my brain's struggling here, but I'm right. I know what to do, but just trying to get it into the code is the harder part. Um, we need to go over to the data frame, find the start of a year, the first date of a year, and at that point, we need to do a calculation across all the previous years and make an entry into their appropriate rows, right? Okay, that makes sense, I think. So what we would do is say for row in data frame dot so we would do for IDX in row in df dot what's that value? Iter rows, I think, right? So for index and value, this returns back an iterator, a tuple, a series of values. This gives us our row. Let's go ahead and print row, and then let's just break right off the bat here so we can see what's happening. Okay, cool. So it's just printing the row here with a name. Okay. So now we're looping over the rows of the data frame. We need to identify so the IPO year we know is this. So we'll say year is equal to the IPO year, right? We would want to get this row dot index. If we print row index 0 and break, what do we print here? Index object not callable. So if you just print row dot index here, we just get the singular index. We index on these values here. No. So we want the date. So if you say row dot name, do we get the name, which is that what it defined as earlier? Yes, we get the index name. Okay, which is that. And so we can, this is just a timestamp object, so we can just take year from here, right? We can cast into this, and we should just get 1986 here next. Yes. Okay. So what we can do is we say if row.name.year, right? If this is greater than the current year that we're on, then this is an entry, right? So we need to make an update here. So actually what we'll say, if it's less than the year, we'll just continue, right? Right off the bat. And so if we don't, we're gonna make the entry clause here, right? So if the row name year if int row name year, so if the row's year is less than the current year we're looping, right? We're tracking our year tracker, then we're going to make this is an update here. So what we're going to do is we have high, low, and stock splits. I'm trying to see where the stock splits and how that affects price. So do you just take the stock split? Would you just take the stock split and multiply it by, or just keep track of how many times it split and then do one final calculation at the end across everything? That's actually something I'm not that good at, is what splits. That is something we have to keep in mind here. Okay, so I will ask this. I'll say, I do have that question also. I have a question. I am doing some back data calculations for stock analysis, and I have a question regarding stock splits. So I'm getting currently the history of the stock, which comes from with open, high, low, close, volume, dividends, and split number of splits, or stock splits for every day in the past. Now, when a stock splits, right, how would I deal with maintaining the state of the value of the position if it were to split on that day? You just have to update it if there's a split, right, in the conditional. I think the portfolio is symmetrical in two things: shares owned and cash. When a stock split occurs, your economic value doesn't change at the moment of split, only share count per share price changes. Mm. Okay, so we have index and row. Rows. We're going to identify when a new row happens, when a new year happens. So right, the year will become row dot name dot year, no matter what. The year will become that once it becomes greater. So equal to year continue. Well, the row will become that. Okay, and then when we have this year, what we're going to do is calculate for row in results. All right, we need to loop over our results so far and do row index -1. So the last row in our results frame, right, which is going to be here. We're going to create, well, we found a new year, so we need to append a row. So results dot append a list, and in here is going to be the initial investment, right? So you're going to add the investment as a starting place in your list for every row you come across, right? So when the year changes, when the year doesn't change, you just continue. Okay, we came across a new year. We came across a new year here. So what happens? Well, we append to our results a new list, which is our starting investment. Then we loop over we need to start, I guess, results for the starting year. You would have to start it with the initial investment, right? You start it with the investment in results for the first year, right? And then you would do this, right? Do an update for so it would start off with invest. So actually, I don't think you would start off with an investment because you're not starting off perfectly in this data frame. Once you come across, you don't invest right off on the IPO. You invest on the start of the year after the IPO, right? So once you come across that, that's when you first invest. So um, if right int row name dot year is less than year, right? You haven't gotten into the first start of the year, um, the first year change since IPO. You would continue, right? If not results, right? Let's do results dot append, right? An investment, right? So you're gonna make an investment if you don't have any results. If you get through here, right? And only do that on the start. Okay, for row in results, right? Now we have an investment in there, which I guess maybe is the same as starting off with an investment in there, right? If you have an investment in there from the start, well, the year changed. So the thing that I'm trying to deal with though is the year changed. You made the investment and then you loop back over. So then I say you continue here. Right? You wouldn't want to update the last row, the row that you just added, right? Because you just made that investment. So making an update to that row, I guess wouldn't change the price at all because it would just reflect the current price that was already updated for that already day, but it's kind of inefficient. So I guess if you say if not results that append the initial investment and then continue, so you don't but that doesn't really handle the aspect of so I think what we can do like what we did before is we just take a list and put in here the investment, right, for the first year, and you would append a new investment. Okay, so you would have your investment in there initially for 1986 of $10,000 on January whatever, 1st or 2nd or whatever, if it was a weekend, 3rd. Okay, we're going to loop over. Okay, we're going to loop over. We're going to say if the row.name.year is less than or equal to the year tracker that we're on right now, which is currently 1986. Right, we're going to continue. So year is 1986. This is 1986 for a little bit. We get to 1987. Okay. We get to 1987. We look at the price. We look at the price of the current row, right? So this would be 1987 here. Boom. We would make an investment right here. So this is the day we would make an investment, $10,000 in 1987, right? So let's just say that we bought the, I don't know, we bought the high every day or the low. I guess the average of the high and the low, or the median of the high and the low. Maybe we'll do that. Or the median of the open and the close. Or maybe we'll just do the close. I think that's probably better. It's just to buy the close. Right? So you buy the close. You spend $10,000 buying the close price. Right? So in 1987, $10,000 would be invested. $10,000 would be invested, and we would need to. Gosh, I'm trash at this. $10,000 would be invested, and then what we're gonna do is loop over the rows results. We don't want to append to it because we already made this investment. Okay, yeah, so let's actually stop, not have an investment in there. We'll loop over the rows where there's nothing in there yet, right? And then we make an investment. We make the investment for today, right? So the investment would be $10,000. And so we would want to have a function, I guess, right? Probably a function called def calc market value, right? You'd be given, we need to calculate the market value of every for row, which is a list of values, right? You would calculate maybe you need, because you need to actually have, maybe you have to have more data than I'm keeping here. Maybe you need, because you have to have the share, the number of shares. Well, you're not adding, right? You're just keeping the same number of shares, right? So $10,000 into Microsoft in 1986 on the first day of 1987 after the IPO year of 1986, right? Would give you $10,000 divided by how many, the current share price would give you how many shares, right? Now you just take that share price or that share count and multiply it by the current price of Microsoft. But if you have a split, I guess you would just multiply your share count by so that maybe that's what you should do first, is first develop a result of the number of shares and then loop over a matrix of all the shares you have, and then loop over the matrix of all the shares with relation to the price of Microsoft at that time, calculating a market value, and then it's pretty easy from there. Because we have to keep the number of shares owned at that given time relative to the number of splits. So what I'm trying to build here is a 2D matrix heat map of each row is a year, and the start or zero position in each row is a 10,000 or X dollar amount of investment in the ticker symbol or in the stock for the first date given a new year change post IPO. So if Microsoft IPO'd in 1986, you would invest $10,000 the first day you can in 1987. Now we're tracking in that row your market value year after year for every column then forward, and then every row downward, kind of is the next year, which would lag behind the following row's columns by a year. Or something like that. But you wouldn't. But could I do it in a way where I wouldn't have to have blanks? Mm. Okay, so it's funny enough that history has a argument called auto adjust, which is equal to true, which will automatically adjust for splits for us. Right? Huh. Hmm. Purchase price $10 in 1990. Just a price $40. So I'm kind of confused because I May I ask, I've been trying to make doing electrical projects part of my hobby. I need Python or C programming languages. Yeah, I got a lot of great stuff in my channel here. You should check out the streams we've been doing and all the videos I've got here. Yeah, it's linked down below. The Discord is. Okay, so let's just think here. So if I have history here, right? There's a lot of pandas data frames functions that I'm not as good at. So we have years is equal to, well, we can extract out the years by going data frame dot index dot to, oh, so this would be dot year dot unique, right? Because it's a index and we get the year of the index and unique. And then we'll do sorted. If we print years here, yeah, we get all the years. There we go. So that's the easier way to get years than what we were doing before. Okay, that has a built-in for it, which is nice. Okay. Okay. We would do for, yeah, so we would do for IDX and day. We'll say trading day in data frame dot iter rows. Okay. We have index and trading day, which is a row in itself. We're going to get the if trading day dot year we would have to get the so we would need to do start year, or say we'll just say year is equal to years index of 0. If trading year less than or equal to the year, we continue, right? Meaning that, right, that it is currently in the year we're on. So if IPO'd in 1986, we're not buying until the first day of 1987, right? So we're going to have to update the year to trading day dot year in that case when it happens. And in the middle here, what we're going to need to do confused. So for each start year, Oh, I suck, dude. I suck so bad. I'm blanking here. For each future year, end price equals to adjusted close on last day of future year. Okay, so maybe we should just try it. Just keep it small with one row. Work our way up from there. We have this so far, which I feel like is on the right track. Hmm. So it suggests to build a um, a heat map. It suggests to build a dictionary of the first trading day of each year, right? So, which is pretty easy. We already kind of have it going here. So let's actually do first trading day of the year equals this, right? And then we have for index. This has to be index actually, right? Because it applies to the index of the trading rate row. So we're going to go into first index trading day of the IDX dot year, right? And we're going to say this is equal to the IDX itself. So that'll give us the first day with the key of year and the timestamp as the index. Okay, right? Okay. Okay, so we have the heat map of years now, or the hash table of years, right? So now we need to loop over which we're not even using this anywhere besides there, so we can just take years index 0, put this here. Okay. So what we can do is now we can say for year in years, and we're not going to do the IPO year. So one forward. For every year in years, what are we going to do? Well, we have we need to do the buy date, right? The buy date is equal to the first trading date of the year given the year, right? We set that up nicely. And the buy price is equal to the data frame dot ilocate I think it'd be locate, and we would locate the by date, right? This is the date of the index, and then the column we're looking for specifically is the closing price, right? Now this is where it gets a little funky. It's telling me like I have to do something with future years. So right now we have to go loop back over the previous years in order to evaluate. Oh, okay, yeah, right. So we have the current. This is basically current, and then we're gonna loop back over previous or future. And calculate that. So for future year in years, if the future year is equal to the current year we're on, then we're going to continue. No, is not equal to, sorry, is less than the current year we're on, we're going to continue. Because it's going to loop back over our years, and we only want to find years that are equal to or greater than, right? Hey Jimmy, how's it going, dude? So for this future year, right, we can do an end date is equal to, right? But we need a last day of the year. So what if I do this? What if I do the last trading day? So if the year is less than or equal to, continue. Else you found one here. And the last trading day is the no, we can't go backwards. So what if we actually save a previous is equal to none here? Right, we would say previous is equal to, we'd have to keep track of the previous year and row, year and index, right? Or previous index. So we'd save index 2 here, go through, but we wouldn't want to do it at the start because it would get overridden at the start. We want to do it at the end. And say last trading day of the year equals to the, but we want to do the previous day. So this would be previous is equal to index, and then you do it also here. Maybe, but you do idx dot year is equal to the idx here. So what this would do is, okay, if we're on 1986 in December, okay, we come across 1987. we're just okay, we're setting for each previous day. We're kind of just keeping track of the previous index and keeping it in our head here. So it's first none. We would then say, okay, it's year is equal to, okay, we're in the current year, so it would be previous is equal to index, which is the current value we're on. Then we continue. We keep doing it until we wouldn't hit this. Previous would be on the previous day. Yeah, I think that would. So this is a previous. Previous here, right? So we would have the last trading day of the year and the first trading day of the year. So we would do, let's just print, I guess let's print first trading day of the year and let's print last trading day of the year and see what happens. So first trading day of the year, 1987. Or this is the last trading day of the year. I thought I'm printing first. $1987, 12/31. Wait, why isn't this working? Oh, so you just keep overwriting the last trading day of the year. So you could say year is equal to idx dot year if, right, year not in first trading day of the year, then it becomes first trading day of the year, right, for said year, right, given the IDX. Else you just keep overwriting the last trading day of the year as such, right? So you'll keep overwriting until you get for that year, until you get the last day, right? So now we'll loop through, we have end date, right? So end date is given the last trading day of the year, given the current year, and end price last trading day of the year. Would be df dot locate end date given close. Okay, you have those things. So now you would take, this is how much your value is, right, for this given year. Value is equal to investment times what? It'd be the change, the percent change in your end price over your starting price, right? You don't need to calculate any like difference or whatever because you can just go based off percentage. So you have end price over buy price, right? Which is a ratio. So if it's 100, it ends over 100, and you bought it for 50. That gives you 100 over 50 would be 2 investment 2x times 2, right? So that would give you your value of your investment as total, right? And so then all we need to do is now save this into our results. So results, right? Which so if we have how do we append results though, right? So this would be results the start year or sorry the by the future year probably goes to the value. But then how would we set up the results matrix? How would we That's my question. Got these shorts on, they're too short. They look like I'm buck naked under here. How would we go about the results matrix? Well, it would be by the number of years. So results is a years by year. So actually, so results is equal to an array of arrays, right? So array, not by how many. Well, the thing is we don't have. I'm gonna ask about this part. I'm a little confused. A little stuck here. So end date. We have a bug here. Last trade of the day given year. Oh, but this needs to be by the future year, right? Because that's what we're looping over here. But we don't have the results initialized. That's what I'm confused on. Hmm. Oh, interesting. You can just transpose with data frames as well. Oh, wow. That's pretty cool. Results year. So you have to build it, right? So we'll have the results here. We're then going to build results key of year, right, is equal to just a list, right? Or is it a dictionary? Well, the key of the year would be next to dictionaries. Given the year and the future value. Instead of equal to, yeah, because it would be a dictionary, and then you set future value in here with key of value. Then you just transpose the data frame simply. So we would just do, we would do pandas, right? It would be pandas pd.data frame of that data frame. Right, so we'd have like mapping is equal to pd dot or make a data frame given the data results to transpose that data, right? That's all you have to do is call dot big T. So then if we do mapping for, or we do with open okay, let's just do that. So now we can just do period here. Okay. So file. Oh, trying to print. Sorry. um, okay. So if we run this, this. Making me laugh. Okay, cool. So this is what we have here. Now let me do this. Um, Maybe I can do. Hold on. There's a Apple has one, right? It's called Cells. What's it called? It's called Sheets. No, what's it called? What is data? What is Apple's Excel alternative? It's numbers. Gosh, crappy name. We're gonna do. Let's go to find this in our repos. Oh, we can't. Okay, so this is what we have so far. Um, cool. So let's see what we can kind of see here. So if you were to invest 10,000 into Microsoft at IP, well, that's weird. That doesn't make. Oh, if you invested 10,000 in Microsoft at the beginning of 1987, you'd have 22,000, 36, 63, 160. Holy crap. That was such a booming time after IPO. You'd have 38 million dollars. Oh my gosh. Wow. Okay. That's crazy. So you would have 38, $1 million if you invested at Microsoft $10,000 the first year after its IPO in 1987. That's pretty wild. That's pretty crazy, you guys. Where's my chat at? Hold up. So, if you invested $10,000 in Microsoft at the beginning of 2026, you'd be down almost 20% right now. So, given Microsoft's track record, you guys. Well, if you bought Microsoft, if you bought Microsoft anytime in the past 3 years, you've lost money. If you bought them at the start of the year. Wow. That's crazy, dude. That's wild. Okay, that's nuts. So let's change this to 1,000 and let's look at what if you put $1,000 into Palantir stock. If you put $1,000 into Palantir stock in 2021, you're down 790. You're down to 200, 700, 3,000, 7,000, 5,000. Interesting. So I want to show the initial investment though. So how can we alter this to showcase the original investment? Um, so for a year in years 1 through 4, one forward, 1987 gets a mapping. So we would add, so that's the interesting part is this shows the this shows the doesn't show the initial investment though. Right. So this doesn't show the initial investment. It just shows the value at the end of that given year. Right. Which is fine, I guess, if it's kind of inferred that 10,000 was initially invested. So let's play around with some more stuff here. Let's quickly um, let's quickly wrap up a fast API data endpoint so we can send this to our front end and we can visualize it there a little bit easier. So let's do a file here. Um, actually, I guess let's just import fast API and let's go ahead and install it. And install Unicorn. Okay, now I have those installed. So we'll import fast API. I guess we'll do, we'll call this main.py. Let's rename this to to heatmap.py. We'll do main.py here. We'll import fast API. We'll do app is equal to fast API. Oh, sorry. From fast API, import fast API. We'll do app is equal to fast API. We're going to do at app dot post. No, sorry. Get. We're gonna do get slash just like that. We're gonna do define home or main, I guess. Which takes in data. So it's going to take in heat map, which is a pandas data frame. I guess is a dictionary. Well, here it's in the form of a pandas data frame, right? Mapping here, transposed. So if we just send results to the front end, then so this would be a dictionary, I guess, and then we have heat map, and then we have info or basic info, I guess, which is also a dictionary. And we're going to return heat map and basic info. So we return those. So if you go UV corn main, okay, we got a server going. Detail missing location heat map message field. Okay. So now we need to return this info, right? So if I just I guess if we just like just take this, I guess. Okay. Let's go here. So this is all in our route. We'll clean it up, but so we're gonna do these can go like that. Heat map. All of this goes in to our function. Okay. We have basic info, right? Which is equal to, for right now, we'll just say, because we're going to receive this from the front end. Right, and so we have this, we have ticker symbol, we've got periods, period, right, which is going to be periods index 10. And then we have okay, that's fine. So then we're going to take periods, place this as a global variable here. This P will be period. We can get rid of this. It's just giving me problems. Am I trolling? What am I missing here? Wait, am I something wrong with my brain? Am I missing something here? Oh, sorry. It needs to be strings. I'm stupid. Sorry, it's been a weekend. Okay. Um, so this would be basic info, key of ticker symbol. Ticker. Key. That'll go away. Cool. Any other issues here? Okay. Okay. So what happens if we return mapping? Unprocessable content. Detail. Missing location, body, heat map, message field, acquire input type, missing. Oh, we're not passing this in. You have to pass these into the function. Out of range float values for float non. Okay, so it tried to float our non-value when. So it's trying to float our nan values. So we need to mapping dot how do you my mapping has nan when sent to front end tries to float 64 the nan. So we can clean it with numpy. So it'd be like, if I have this, so you could just do mapping dot replace. So it would just be simple as this, mapping dot where panda's not NA mapping, else none. So you'd go to mapping where pandas is not NA, else none. So you just filter out mapping where it's not NA, else you put none for those values. So we got a return mapping to dict here. If we run out of range, out of range float values are not JSON compliant, none. Shoot, so you're trying to do JSON encoded structure that can still contains non-values. So then if you just do would you import JSON here and dump? Object of type data frame is not JSON serializable. You convert it to a dict and then dump it. Okay, there it is. Okay. These are backslashes, so they're new lines for formatting. So if you print it, because now it's going to give you all these new lines, which is not really what we want. Return mapping to where? What else? I don't need to return. What if I just return mapping here? Or sorry, results. Stomach hurt. It's growling. Okay, so now we're getting this 2021. Huh. Oh, each of those, yeah, and some values for each of the things. So 2021, these are all, if you invested in 2021, these are starting values, okay. Okay. Um, Now the thing is should I send this as this or a list on a list? Well, probably better this way. With dictionary to dictionary. Okay. So send results to the front end. That looks good. So the thing is we need to send results. We also need to send basic info. Right, there's basic info here. So we'll send a dictionary with results, and then results, and then basic info as right, we'll send that. So now we should be able to go through there and get those out pretty easily. Nice. Cool. Okay. Oh, sure. Okay. Cool. I think that this should still work. Daytime index on object not callable. Okay, so you just have to do. I've never seen it format like that before. Huh. Okay, cool. So yeah, we don't even need to call it a rows and get the rows either. We just need the indexes of the rows for that function, for that loop. And then for every year here, we get the row. Nice. Okay, cool. So now we have, what do we do here? Well, what do we have? We have a heat map, right? This might seem kind of weird. Like, what is this? What does this look like? Well, let me open up my Apple numbers here. Oh, hold up. Numbers. So let's do. So right, you're gonna have to provide basic info on the front end, and then you'll get that. Investment in price by price. Okay. Cool. So that's fun. Now what we can do is we can display it to the front end visually with a heat map, which will be cool. So we'll just make a table. Make a table, or I guess we could just import it to Excel. And do like if you hit $1 million, maybe it turns yellow. It's green if it's okay. All right, guys. I think I'm gonna call it here for today. I'll probably come back on a little bit later and stream again. Maybe do some reading and some stuff. But this was a fun one. Um, it was pretty. It was a little bit more challenging than I thought, as the logic of the algorithm here was a little bit more complicated than I originally anticipated. We refactored a few ways rather than doing everything kind of all at once or whatever. We got the years first, and then figured that we needed to get the first and last days of the trading year, and then index into our data frame for those days using kind of like a mapping, which helped out. So if you guys enjoyed this one, this was coding in Python. What we did, we were successful. So it might not look like crazy, but look what we did. So I'll just quickly write in here. Um, I'll quickly write in here a comment and say with open. We're gonna do quote results dot csv, and we'll open this up in write mode as file. Let's do we want to do pd dot data frame. We're going to do it on results dot to csv, and we'll save this as we'll write this to file. Right, and so if we run this, forget that it's hooked up to an endpoint, so we can't really run it unless we refresh the thing. There we go. So now we got results here, there. So what did we do here? What did we do here? What we did was we I'm going to change the symbol to one that's a little bit better. Let's do Apple. Actually, I kind of want to look at, I kind of want to look at, I want to look at, I want to look at CRM, Salesforce. And let's say you invest $10,000 into Salesforce. Okay, let's see what happens. So this is what we get here. What is this? Okay. Wait, what happened to our thing? Huh. Is this working appropriately? 2005. Well, results is kind of do that. I think we want to do. Right, I think that that's fine, right? I think that that's okay. Oh, so we need to transpose. That's why the CSV looks funny. There we go. Okay, so what is this saying? Okay, well, if you invested $10,000, I'm gonna do a different company. Let's do someone everybody knows. Apple. Oh shoot, I always do that. So if you invested $10,000 into Apple, which IPO'd into 1981, right? $10,000 into Apple, right? If you invested $10,000 into Apple, um, what is this selling you? So $10,000 into Apple in 1981. So this is how we built this. So you don't invest on IPO day. You invest the first day of the year after the year of the IPO. So if the IPO is in 1980, you would invest the first day of the year in 1981. You don't invest the IPO year. You invest the first day of the year after IPO. So initial public offering. So if you invest in Apple on the first year after IPO, $10,000, you would have 6,400 after the first year, 8,000, 7,000, 8,000, 6,000, 11,000. You wouldn't have become profitable in Apple until one, two, three, four, five, the sixth year. And then seventh year, 24,000, 25,000, 34,000, 36,000, 18,000. Hold up. um, 34,000, 36,000, 18,000, 24,000, 20,000, 13,000, 8,000, 26,000, 65,000, 18,000, 27,000, 18,000, 27,000, 81,000, 182,000, 215,000, 503,000. Oh, this is a brutal. Imagine you're watching your account go from 81,000, 182,000, 215,000. Where's that at? 215,000, 500,000. Why do I keep skipping here? 503,000 and then back down to 216. So you in these 3 years, this is a brutal year. You went up by so much, 215 to 503 and then back down to 216. Ooh. See, I did this project because I had a comment in my Discord the other day asking me, I won't air the person's business out, but they asked me. I get a lot of comments. We talk about stocks and stuff in the Discord quite often, and I get a lot of comments, about investments and things. And this guy asked me, "Hey, I'm seeing a lot of stuff online about the market, and I'm wondering if I should sell and cash out my Roth IRA." And this guy was like, a young 19, 20-year-old guy, 21-year-old guy, and so like So I had to we had to talk him off the ledge in the Discord, um, because it's just like, dude, some of these your retirement date isn't like till 30 years in the future, and you're only 21 years old. You're retiring as a longer period than you've been alive, right? Your period to retirement is longer than you actually have been alive. You've really got to have some perspective the on the aspect of time, and just how it's not small, right? Time is or it's not you don't have a lot of it, but time you do have. There is a lot of time in terms of like stock market things, like, right? So you have to shift your mindset. And yeah, you're taught like, oh, you don't have a lot of time in life, you need to do what you want now. But the market is a different mentality, where it rewards those that have patience and that spend time in it, and can and handle those swings, right? This is Apple. You went from 23, 20,000, 25,000. So let's take a closer year. Let's say you invested $10,000 in the year I graduated high school, right? Let's say that when I graduated high school in 2017, let's say I got $10,000 of money, and I was going to look to invest stuff. I got some for my college graduation. Let's say I got 10,000 bucks, right? Woo, that'd be nice, right? Or high school graduation, and I threw it all in Apple. Well, after the first year, I'd go to 10,000 to 14,000 to 26,000 to 48,000 to 64,000, back down to 47,000, right? You got to be willing to stomach this $20,000 fall, then back up to 71 to 93 to 101 to 108, right? Like, so $10,000 invested back when I went to high school, when I graduated high school, into Apple, rather than $10,000 invest. That's crazy, actually. That's actually really crazy, you guys. Had I put $10,000 into Apple stock rather than $10,000 into college tuition, I would have had $108,000 in growth versus a college education. So, man, dude, the power of investing into solid, reputable companies is really quite crazy. And I honestly, the more and more I do the math on the stock market and realize like the investment vehicle and wealth generator that it is, the more and more I find that a 9 to 5 job just makes zero and zero and zero, so more less and less sense. Like, it's just like I maybe have that gambler's mindset, right, where I'm just skewed. But I it's just so hard to justify 9 to 5 work for minimum wage when, you know, but it's just as hard, right? How can you find these investments? Well, I mean, everyone knew Apple was a reputable company all through this point. You just had to put $10,000 back when I graduated in 2017. You had over 10x, $108,000, right? So you got to just be willing to hold on, right? $10,000 in Apple at the start of 2026 here is only worth 107. Is 10,000 is only up $700 right now. So if we compare that to 2017, well, you were down actually the first year. Well, you're up actually 4 Gs in your first year, so you had a crazy come up. So let's look at something maybe more familiar, like 2015. Right, 2015, you started off with 10,000, you dropped down to 9,000 after the first year. 11, 16, 15, 29, 53, 71, 52, 78, 10, 102, 112, 120. Right? Right? And it's also interesting, necessarily more time in the market, an additional year in the market. This is also kind of interesting because you would think like, oh, if I bought in a year earlier, right? If I bought in a year earlier, I would have more money, right? That's what some people would think. Well, look at this year right here. Look at the year 2016 to 2017, right? Or sorry, I'm sorry. Um, 2016 to 2015 to 2016, right? This is that concept of the price that you pay for a stock today absolutely matters tomorrow, the next day, the next day, the next day. Yes, it is probably a good idea to buy into blue chip companies. But if you're buying into blue chip companies at all time highs, you run the risks of buying in at periods where it might take a year. In this case, it took an additional year. This person that bought in 1 year later in 2016 was able to actually grow $2,000 more than a person that bought in 2015, right? The price you pay and the valuations you come up with for companies really matters, right? You don't want to just be, if you buying in all-time highs just because people are buying in at all-time highs, right? You want to be running your projections, running your evaluations on these companies and identifying your fair market value and striking when those price targets hit and riding the waves and letting it ride. Right? I think that this is a really cool project. Thanks so much, guys, for being here with me today. So we can continue to take this further by we routed this to with Fast API really quickly to a front end, right? We just routed it really quickly here. So we can take this data and we can display it tabularly with React, and we can just make like a heat map, right? You could just do conditional formatting on color grading for the various values, saying like, okay, if they're greater, continue to become more and more green until you hit like $1 million. You're like make it like a pretty like a yellow or something, right? And we can make like a nice heat map to visualize this data. Thanks so much for being here and hanging out with me today. If you guys have any questions about what we did or all this stuff, appreciate it. We did get a little bit tripped up. I will be straight up. We did get a little bit tripped up in the actual meat here of the algorithm. It doesn't look that hard. It's only about 10 lines of code, but um, it's kind of crazy. It's crazy how only 10 lines of codes can really trip you up. But we were able to work through it. And we had to ask a couple questions, but anyhow, what is the relative value of 10K to yourself at 19 years old versus the stock appreciation of 10K in stock appreciation? That's another interesting question, right? What is the relative value of $10,000 to yourself at 19 years old versus the stock appreciation of 10,000, right? So what could you do at 19 years old with this 10,000 versus putting that 10,000 into, Apple and letting it sit, right? Um, it's just food for thought. Like, could you take that 10,000 and grow it with your college education to 108,000 in that same amount of time? I don't know. Probably not. I'll be honest. You probably actually you went into debt for the college education. You spent $10,000. You got an education, but then you had to probably go even further. So now you're maybe negative 50 in the hole with no Apple stock, and now you're starting out from a disadvantage, right? In terms of debt, you have to climb back up to break even, and you're fighting wage increases, which aren't gonna happen. So I don't know, dude. Like, let this maybe be like this is actually a pretty eye-opening lesson here, right? The data shows you, right? Like, what if I just hold on. Let's just take our data. Let's feed it. This brings up some interesting philosophical questions, right? In the year 2017, when I graduated high school, if you put $10,000 into Apple stock, by the time you are right now, about 9 years later, you would have about $100,000 of investment in Apple, right? Had you have taken that $10,000 and went to college and put yourself further into debt, you would have to climb, out once you graduate, get a job, climb out of that debt, then finally surface, then start making investments, probably around the time that you already have $100,000 in Apple growth. So this just weighs the pros and cons, I guess, of personal investment in yourself and the price of college and the lack of return thereof on wage growth we've seen, and how maybe prioritizing investments into, now obviously you would have to know that Apple was going to grow at these rates, but it's a fairly blue chip company, and by starting at 2017 you have lots of, all the way back to 1980s or whatever, of historical data to pick from, and you can see that it's fairly reputable. So a $10,000 bet into Apple at 2017 really wasn't that big of a shock. So, or that drastic of a bet. So based on this information, what kind of philosophical approach or whatever viewpoint do you have? You're bumping into a real tension here, but it's easy to slip into the misleading frame if you're not careful. First correction. Your Apple example is back-tested hindsight. It feels like a reasonable bet in 2017, but in reality, nobody in 2017 had access to the path your heat map assumes. Even in blue chip, doesn't assume guarantee anything close to that trajectory continuing. So the core idea to challenge is, I could have chosen Apple instead of college and Epic ahead. It's not a valid comparison unless you assume perfect foresight and zero risk constraints. Comparing a guaranteed cost to risky asset, college costs, known upfront, deterministic debt, immediate liquidity loss. Stock investment is uncertain outcome, drawdown risk, requires liquidity, discipline, and survivability. If you're 18 in 2017, the real trade wasn't college versus Apple gains, it was investing versus human capital, investing in human capital versus taking concentrated equity risk at the time when you had no income base. Those are not equivalent financial instruments. Survivorship bias, obviously. The real economic trade is optionally versus leverage. College at its best buys baseline earning power, network access, career optionality, reduced probability of income collapse, right? The deeper philosophical point. This is the interesting part. What you're noticing is college isn't bad. It's this modern wealth isn't increasingly driven by ownership of capital, not by labor. That creates real tension. Wages equals linear growth, capital exponential growth. So yes, early capital exposure matters a lot. Most people only reach meaningful investment capital because of stable income streams created by labor. That's the bootstrap problem, right? You have to get the job in order to get that income. A more accurate mental model, instead of should I have invested in apples instead of college, think how do I get more investable surplus as early as possible without sacrificing survival? But it's interesting with the investment vehicle and the data statistics of the probability of the stock market increasing, especially if you're investing in, like, let's say, like ETFs, right? We could do the same experiment for ETFs and probably find some similar examples. So, yeah, you can say, oh, there's risk involved, but is there really that much risk? There is risk if you're currently looking through a vision of the data where the most of the risk has been averaged out or hidden by aggregation. Your intuition is partly right though. Broad ETFs change the picture a lot, but they don't eliminate risk, they change its shape. Stock market always goes up is only true in a specific sense. If you zoom out over long horizons, major indexes like the S&P 500 have a straight upward drift. That's real. But the statement hides three important details. It's not smooth, not guaranteed, it's not uniform. So yes, up over time is statistically true, but misleading if it interpreted as low risk. An ETF like an S&P 500 fund removes single company failure, but does not remove systematic crashes, multi-year drawdowns, etc. Your heat map is implicitly hiding drawdowns. What your model shows is if I stayed fully invested, I eventually win, but it doesn't show how long you were underwater, how many years you waited to break even, what happens if you had to sell during a downturn. So this would be interesting. So I guess we could take this data further, and now that we have the data calculated, rescan it, calculating, average time to profitability, or average percent return per X amount of time, or other, ratio data based statistics to provide you a time based factor on your investment. This is exactly the right direction. What you built so far is a state matrix of wealth over time. The next step is turning into a distribution in time to event statistics, which is where real insight is. Right now, you have what happens if I invest X and hold until year Y. Now you want to answer how fast does it recover? How often does it? How stable is the path? The key upgrade is shift from values to events. Instead of only storing portfolio value, derive events like time to break even, max drawdown, probability of being underwater at time t, return distribution of fixed horizons, annualized return conditional eventually a year, right? CAGR, um, okay, that's pretty cool. Cool. That's a good starting place. If you guys want to add to this, message me in the Discord and I will post it to GitHub and make it open source for you guys to potentially push to for GitHub or for the Discord people. So join the Discord for free. Also subscribe and like to this channel. It's everything's here for free. Sign up for Code Crafters. Use my link. I don't think I have it in the description, unfortunately. Here, let me grab it. Okay, here. Um, use my link on Codecrafters to maybe edit one of those videos and get it uploaded for the reading that we need to catch up on, and then we'll come back live maybe a little bit later. So let's catch up on some chats. Hey Lane, how's it going? Priya, sir, where did you learn for this? I self-taught myself reading books here live on the channel. So if you, I've recorded pretty much everything live here on the channel. So if you're interested in knowing what's going on, it's all here. The money invested now is worth money earned later. Hey, bro. Hey, Rizkid. I didn't get the logics of Python. Also, I can't understand a lot of how fast API is working. Did you ever face this? Really quickly, yeah. So before we sign off, I'll just show what we built today. This is what we built. It's this cool data cascading visualization here that shows you if you were to invest $10,000 or some X amount of investment via some variable, if you were to invest some amount of money into a ticker symbol for some period of time, right, of history, right, if we went back over and calculated what would be your return year after year, right, this is what we get. So you're able to, if you invest $10,000 into Apple in 1981, you would have $6,000, 8,000, 7,000, 8,000, 6,000, 11,000, 24,000, 23,000, 20, 25, 34, 36, 181, or 18,000, blah, 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 all the way up until you would today, $10,000 investment in Apple would be worth to 24,700,693 So that's how crazy, the power of compound investing can be. Um, what job, if you started in the 80s, would pay you over $24 million on a simple $10,000 investment? Probably nothing. So, like, the power of stock market's pretty crazy. And this kind of shows you each year, right? So 13 for this one. And it also kind of shows some good representations of like it's good to get in at certain times and stuff. So thanks so much for being here. We're hopefully going to cascade this up to or push this up to front end so we can do like a visual heat map rather than it just being numbers. So I'll see you guys in the next one.